Yeah, good evening. Today we'll try to solve Wipro previous coding questions. The first question is, write a program to print the sorted, non-redundant occurrences of elements from the input. So here the text to be underlined is sorted, non-redundant occurrences of elements. That means some elements are occurring redundantly in the input. Okay, so we need to eliminate such redundant elements and we need to print the elements in sorted order, and duplicates you need to remove. Okay, so it is nothing but uh, you might have uh, solved a question removing duplicate elements from array. Okay, so it is other way of asking the same question. Sorted non-redundant occurrences of elements. Okay, so what is the input? In examination, he gives both input and output, and with some sample input output, he explains the logic. Okay, so input contains, first line of input consists of integer n. This is the number. Okay, so representing number of elements. The second line consists n elements separated by space. This is how your input is present. Okay, so you do not need to enter this input. Please remember. Okay, so this input is already available in test cases. Once you start executing your program automatically reads this input from their test cases. That is how their online environment is designed. Okay, so your program think that input is already entered. Okay, so you write code in such a way that your program reads that input from their internal files. Okay, so how to write that we'll discuss today. Okay, now what is the output from your program? Print the distinct elements in sorted order. Okay, so example, if you look into sample input is first number 12 is given. That means there may be 12 elements in your input. This is the number that is indicating this. Okay, so then the second line contains 12 elements. Okay, these are the elements 1, 4, 3, 6, 5, 2, 3, 5. See, some elements are repeating here 4, 5, 4, 2. Then what is the output? Only distinct elements in sorted order we need to print 1, 2, 3, 4, 5, 6. This is how the output should be printed. Now, given such kind of question, okay, so spend 5 minutes, 10 minutes to understand the logic and get the logic on paper. Write some pseudocode kind of thing on the paper so that you can write the program quickly. Okay, so if such question are given, how to develop pseudocode or some logic on the paper. Okay, so let us just see. Let me open some whiteboard for you so that we can discuss the logic. Plain white paper I'll open, right? Okay. Now, what we need to do is we need to store these elements in an array. Yes or no? These elements we need to store in an array. Now, after storing the array, how to remove duplicate elements or how to print only distinct elements in sorted order. Okay, so that we need to identify the logic. Now, I'm just copying those elements here. Okay, 1, 4, 3, 6. Okay, so what I do is I'll just remove some of the elements, or is it okay? Right. Okay, so this is the input. Okay, now what we need to do is given such a input. Okay, so see here 4 is repeating here 3 times, 5 is repeating. Okay, we do not know which elements are repeating here. So to find out that, what we need to do is the very first thing in the logic is better you sort these elements with duplicates. Okay, better you sort these elements along with the duplicates. Okay, so what you will get if you sort these elements? If you sort these elements, what you will get here? Okay, so first 1 you will get. Okay, so next 2 repeated 2 times here. Okay, so 2 repeated 2 times, 2. and same 2 will appear here. Okay. Then 3 appearing 2 times here. Okay. So then 3 appears 2 times in the sorted list. Okay. So then 4 appearing how many times? Just see here. 1, 2, 3. Okay. So 4 appearing 3 times here. Okay. So then next 5 appearing how many times? 1, 2, 3. 5 is also appearing 3 times here. Okay. So then 6 appearing only 1 time. Okay. So this is how your sorted array looks like. Okay. So this index, this is the index 0, you know. Okay. So this is index 1. Okay. So like this, your index continues. Okay. So now this is how the elements will present in the array. Okay. Now it becomes very easy to pick only distinct elements. It becomes easy to pick distinct elements. Okay. So what you can do is you can just take a variable which is called as a unique or something. I am just naming this variable unique, which stores only unique elements. Stores only unique elements. Okay. So what I do is I consider this first element as the unique element. Okay. So if this is the array A, for example, assume if this is the array A in which these numbers are stored in sorted order. Okay. So this first element I consider as the unique element A of 0. A of 0. Okay. Then immediately you store this in a, that means all distinct elements you store in a some other array. You take one more array, and wherever you find a unique element, immediately you store that in this array. Okay. So assume call this is the array called as a result array. This is called a result array. Okay. Array name is result. Okay. So this is at 0, this is 1, this is 2, this is 3. So to keep track of these locations for this array, we need to declare one more variable. Say, for example, J is keeping track of these second array indices. Okay. So first array indexes will be tracked by some other variable. Say, for example, I. You can take different variables. Okay. Now unique is equal to A of 0. I got one unique element. Immediately I store this in the result array. Okay. So then I go on checking whether there is any next unique element. That means from index 1 onwards, I write a loop in such a way, I write a for loop in such a way that from 1 to last element. Okay. So from 1 to last element. For example, if there are n elements, okay. So up to n minus 1 position, I go on repeating. Okay. So 1 to n, for example, n elements. N minus 1 positions, I go on repeat this array. Okay. So 0 already unique element I got. Then I check whether the second element is not equal to this. Yes or no? If the second element, what is second element? 2. 2 is not equals to unique element. What is unique element? Unique element is 1. Unique element is 1. So 2 is not equal to this unique, then this will become the unique element because it is not a duplicate of 1. It is not a duplicate of 1. Okay. So this will become unique. Then I say, I write a code like this. Okay. So then I write here unique is equal to something like A of I. For example, the index is I. You can assume A of I. Unique is equal to A of I. So this 2 I will store in unique. Okay. So then immediately I copy this into result array. Okay. So that I got a next unique element here 2. Okay. Like this I repeat this for loop. Then I check with the next element. Okay. Now you can see here next element is 2. Okay. So this next element is not equal to unique. Here I write the logic. I have taken the numbers here. Assume that this is the logic here. What is the logic here? Okay. So this A of I, you can say A of I here. Okay. So if A of I not equals to unique. Okay, so if a of I is not equals to unique, okay, so if not equals to, then I say that unique will become a of I will become the unique. Okay, so in this case, now see next a of I contains 2. 2 not equals to 2, false. Then this is not executed. Okay, so then loop continues, goes to the next element. Okay, so then 3. 3 not equals to unique. Unique is what? Unique is 2 here now. So 3 not equals to unique. Yes. Then unique will become 3. 3 will become unique. Unique contains 3. Okay, so that immediately I copy into result. Whenever I find a unique element, I immediately copy into resultant array. Okay, so like this 1, 2, 3, 4, 5, and 6. All the unique elements will be copied into this resultant array. Now, if you print this resultant array, now that gives the distinct element or non-redundant occurrences of elements from the input, because already this array is already sorted. So you will get automatically, when you print this, you will get the sorted list of numbers only. Okay, so this is how in rough you need to develop some pseudocode or some logic. Okay, once you get this logic, then you can implement this logic in one of the languages. You choose C, C++, already online environment, there will be compilers available. So you have to select corresponding compiler. Okay, C, if you select, then C environment you will get, and you can write your code and you can compile and execute. When you execute, you will be seeing how many test cases are satisfied. Test case 1, green mark you will get like this. Okay, so right mark you will get test case 1, test case 2, test case 3, test case 4. Okay, so with the green mark you will get these tick marks. Okay, so that indicates all these test cases are satisfied. If something red mark if you appear, okay, so in cross mark, that means this test case is not satisfied as per your logic. Okay, so you look into, because he gives some constraint. For example, array size is of size 1000. Okay, so if you have not taken care, you have declared only array of size 100. Okay, he may enter 900 elements, then your program won't read all the elements. Okay, so in such cases, this test case is not satisfied. Okay, so there you will get a red mark. Okay, so whenever you get red mark, you try to look into the code why the test case is not satisfied. You do not know what is the input present behind the scenes. Okay, there is one y for 1 to n minus 1. That is what I am, yes, Rohan. See here. So the first element, a of 0, I have already stored in unique. A of 0, I have stored in a unique. Okay. So now I have to search from first number onwards. That means the next number will be in index 1, no, in the array. Next number will be in index 1, no. So that's why I have to start searching for other unique element from 1 onwards. That's why I have taken here this I started this for loop starting from 1 onward. Generally, when you access an array, will start from 0. Okay, but that 0th element is already taken out. Okay, so that's why from next element onwards I need to set. So that's why I have taken this for loop starting from 1 to n minus 1. Okay, this is the first one. Then your second doubt is, what if we got the output, but the code is less and steps are missing? I did not get why n minus 1? Because n gives number of elements. N tells number of elements in the array. Okay, if number of elements in the array are, for example, you will take this case. Okay, so this is 3, this is index 4, this is index 5, assume this is index 6, this is index 7. Okay, now this array contains a, okay, so assume that there is some other element 8 is there. Okay, and there is some other element 9 is there, assume. Okay, So when you say number of elements in this array, 1, 2, 3, 4, 5, 6, 7, 8 elements are there in the array. 8 elements are there. Okay. But where is the last element stored? Last element is stored at position number 7. Okay. So that means your n value is 8 here. Your n value is 8 and the last element is stored in index 7. Okay. So that means you need to access only up to 7th index. That's why I have taken n minus 1 here. Okay. 8th index is not part of this array. Not part of this array. Your last element is at index 7. So that's why we need to take n minus 1. Is it clear? Okay. Right. Now, this is how we should develop the logic. Okay. So on rough paper, you should develop the logic like this. Now you can code the same logic and you can execute. Okay. So what I do is I open an online compiler and will directly write this in online compiler so that we can directly execute. Online C compiler we can open. And because if you open online compilers, there will be the latest compilers. Okay, so you remove everything and you start writing code from the first step onwards. Okay, so what is the first step in our C program? You need to include the header file stdio.h. Okay, so then write the main function int main, then open and closing curly braces. Okay, so because this is the advantage in even in your online editor also, open immediately closing brace will appear. Okay, so no need of checking separately for them. Okay, so even if they are not appearing, you should take care. For every open brace, there should be a closing brace. Okay, right. So now we need to look at the input and output format. As per that, you need to see here, there are two lines in the input. First line contains number of elements in the array. Okay, so for that, what we do is to read number of elements in the array, we declare a variable called as a n. Okay, then immediately you read n here. Okay, so please remember, you should not write any printf kind of statement. Generally, in our conventional programming in lab, when we are practicing, we write that enter n value, that kind of things, because this is the program we are executing in lab and we should give a prompt message to the user. That's why we write a printf statement before scanf. But here in online examinations, already input is available. Okay, so that's why we need to write directly scanf function. Okay, so don't write printf statement, but if you write a printf statement, then your input is not matching with the expected output, then your program won't be executed, compiled correctly. Okay, so scanf, immediately read the n value. Okay, so %d, scanf %d, then say comma n, address of n. Okay, so that means this reads the first line. 12 it reads. Okay, so that means if input is already available, so this 12 it reads and that will be stored in a n. So afterwards, what we require to store these numbers, we require an array. Okay, so already number of elements are given here. So that's why what we can do is we can declare an array. Okay, so array of, say, a of size n we can declare. Okay, then immediately you read elements into this array. So for int I is equals to 0, then I less than n, then say I plus plus. Okay, so read the elements. How to read? Scanf %d, comma, address of a of I. So variable choosing, names of the variables, you can choose as per your convenience. Okay, so this for loop, because we need to read more than one element. Okay, so we can use a for loop here. Okay, so in latest compilers, you can declare the variable in the for loop itself. I value you can declare here itself for int I is equal to 0. Like this you can. Okay, otherwise you can declare I here also, no problem, directly you can use. This is our conventional way. Okay, so latest compilers, contains this facility. Okay, so if you habituated for this, use the same kind of notation. For I is equal to 0, I less than n, I plus. So it reads all the elements into the array. Okay, so these elements will present into our array. Okay, so as per our diagram, you see they are present in the array. Okay, so now what we can do is, now elements are in this array. Okay, so now we need to sort these elements. We need to sort these elements. Okay, so for that purpose, what you can do is you can use predefined library function. Okay, so predefined library function in C, there is a predefined library function qsort is available, which is quicksort technique. Okay, so if you look into, otherwise what you need to do, you need to define a separate function like bubble sort, selection sort. You have written, you have gone through, no? So that code you need to write as a separate function, sort function. Okay, so if you know predefined function, you can use it directly, and it is better to use predefined function. Okay, so quicksort, qsort syntax I'll show here. If you type in Google, see qsort in C, qsort in C, if you type, then you'll get it's a syntax. Okay, now see here, qsort. Now this is the qsort function. The first is base, second is number of items, third size of each item, and fourth one is a function, comparator function. Okay, so see here, 4 arguments it takes. Okay, so once you remember this, it saves lot of your time. Predefined functions, if you use, it saves lot of your time and they execute faster compared to your code. Okay, so what are these 4 parameters? First one is our array. Second one is number of elements in the array. Size is size of each element, whether it is integer or float or character. Then last one is a compare function you need to write. I'll tell you how to remember this function. This function definition you need to write here. Okay. So I'll write this code here. Now see. So qsort, what is the first argument? Our array. What is our array? A is our array. Array name. Okay. Then number of elements in the array. N is number of elements in the array. Then size of each element. So here you say size of, what is the data type of each element? Integer type. Then you say size of int. Okay. Each element is integer type, because he may be using 32-bit compiler or he may be using 64-bit compiler. We do not know. Okay. So, or 16-bit compiler. So on different compilers, size of integer is different. So that's why if you just write size of int, based on his compiler, int size will be decided. Okay. Then the fourth argument, this is very, very important. Just see here, you write here compare function. Just you write the name of this compare function. That means you are calling a compare function. That's it. Your list will be sorted here. Okay. So this function you need to define here, compare function. How to define? Before main, better you define this function. Okay. So compare function, say void, say compare function. Okay. So 2 arguments. What it will do is, in compare function, it takes the first number and second number. First number and the second number, then compares and returns some value. Internally, there is some code we do not know. Okay, but just remember the logic. That means the first 2 numbers pointers we require here. Okay, so for that purpose, you need to define here void star a, first pointer, comma, second argument is void star b. These are the 2 pointers to first 2 elements. Okay, so what it does, it subtracts first element minus second element. Okay, so how you can access first element? You can say star a. Star a indicates first element minus star b. Okay, so this value it returns. So this you include in a return statement. This you need to remember instead of remembering bubble sort and selection sort logics, writing them. Okay, so if you remember these 2 lines, then automatically you will get a predefined function. Okay, right? So, but here you need to remember one thing. Here star A and star B are void pointers. Okay, but our elements are integers. In the array, our elements are integers. So that means you need to typecast these void into integer pointers. Okay. So before star, what you do is you write them, you typecast them into integer pointer. You say int star here. Okay. And before star here also you say int star, so that they will be pointing to integer numbers. Now this gives correct output. That's it. Only these two lines, if you remember, then this function is available. Compare function. Okay. Now see, now your elements are sorted. Okay. So if you want to confirm this, just you print the elements. Say for I is equal to 0, I less than n, then say I plus plus. Say printf percentage. Just this is not part of the code. Just to confirm, I'm just printing. Afterwards, we implement the logic. Okay. So then say a of I. A of I. Okay, right? So then say return 0. Our actual logic we will implement. First, we run this code and we will see. No, this is already predefined function. Okay, this is already predefined function. Don't bother about this. This only you need to remember. This you need to remember. It is already code is written for this. Qsort is a predefined library function. Where is it available? It is available in a stdlib.h. You need to include this hash include stdlib standard library.h. It is a predefined function. Okay. So for that, it is already given this computer or compare function. Okay. And the code will look like this for this. Okay, two arguments, void star a comma void star b, and star a minus star b you need to do. And before subtracting, better you convert. This is a void pointer here. You convert them into integer pointer. If you have used floating point numbers, then you have to write here float star. Okay, but our input contains integer numbers. No, better you convert them into int star. This you need to remember. If you remember this, you will be getting a predefined function available to you. Clear, Rohan? Okay, right. So now I am running this code so that we can see the output sorted or not. Now see here, extern void qsort void star base size t. Now what is saying expected something. Okay, so some message we are getting here now, but still it